Is g of x continuous at x equals 1? Yes or no? Yes. Okay, I can put 1 into here, right? Get a nice little answer out of that. So I can say, whoops, we don't want that. There we go. Okay. Is g of x continuous at x equaling negative 1? Yes or no? Sure. G of x? G of 1? 1 squared plus 5? It's continuous there. How do I know that? Because g of x is a polynomial function. What do you know about the continuity of polynomial functions? Where are polynomial functions continuous? Everywhere. Okay, good. So it says the function g is continuous at, these are the points of consideration here. Yes, it is. Now it says, and function f is continuous at g of c. Now that's going to be a little different here. So let's put number 2 here. So now the question is f of 1 now let's put it this way. Is f of x continuous at what? G of 1, and is it continuous at g of negative 1? G of 1 and at g of negative 1. Okay, so what is g of 1? G of 1 is 6. G of negative 1 is 6. Is f of x continuous at 6? Conclusion? Therefore, h of x is or is not continuous at x equaling, and then you fill it in. Okay, is h of x continuous then at what? 1 and negative 1 or at 6? Which one do we pick up? Is the composite then continuous at g of c or c? At c. Okay, so let's see. Is the composite continuous at 1 or negative 1? Is or is not? What do you think? Is not. There's h of x. Okay, so is not. Okay, so we're using the knowledge about function g of x and the output of g of x and function f of x, and that tells us something about the composite function. Okay. Yeah, how did I decide to do that? If I'm looking at the composite function, I see that it is going to have a problem there. Okay? Now, what if I didn't know the composite? Well, I probably wouldn't know f of x or g of x either. Okay, so I'm given those. Now, could we be given h of x and not given one of these two? Yeah, we could. We could work backwards to that. But I picked up 1 and negative 1 because I knew something was going to happen with that. Okay, let's go on. Intermediate value theorem. I love this theorem. This is one of my favorite theorems. So let's take a look at this and see why you're going to love it too. Okay. I'm so confident about that. It says the function f is continuous on a closed interval AB. Now, right now, we need to talk about what that means. Because if we don't know what that means, then we don't know what the whole rest of this is. So this is your participation piece for today. I'm going to ask you a question. And let's see here. If I can spell right. Okay, now I'll get it eventually. I'm giving you, well, you'll see when you get it. Okay? Look on your Inspires. You should have that question. Okay, I've got one right answer so far. Two right answers so far. Three. Got four right answers. Got five. Six. Got four more. Got a few more people to come in. Okay, getting some good right answers there, but I'm getting some others that I'm not as pleased with, and you're going to have a little bit of work. Okay. We've got 8 right answers. You got 6 more people to log in. Please log in because this is going to be my way of determining that you participated in class today. See how many people you need yet to come in. 6 more of you. Some of you I see are still typing. There we go. Okay. Now, if you're not correct on this, you must make sure that you understand this. Because the book uses this notation. 4 more people. Let's get it in here. It uses this notation. It depends on your knowledge of this. You know, again, as I've said before, this whole course is not really teaching you new mathematics. It's just teaching you new ways of thinking about the mathematics. And so if we don't understand the language of the mathematics, then we really are going to be hurting. Okay, here we go. Let's take a look at this. I'm going to stop the poll. Let's take a look at these and see what we've got here. 2 less than or equal to x, less than or equal to 3. Yes, that's it. So if you have that answer, you are correct. And if you have something other than that, there's a few that are correct below. You just didn't say it quite that way. It is not a point. If it's a point on the plane, on a line, whatever, on a function, it would have, for one thing, it would not have brackets. It would have parentheses. Okay? So we have to understand the notation here. It is not that x is less than or equal to 2 and less than or equal to 3. If you're less than or equal to 2, which is if you take this and read it from right to left, you're saying x is less than or equal to 2 and less than or equal to 3 at the same time. What you're really saying is that it's only less than or equal to 2. You've got an intersection going on, and that's not the way you want to read it. Maybe you just typed it in wrong. Maybe that was it, but 2 of you did that. Why is this not correct? If it's the brackets, it means it includes the endpoints. Okay? The value in between any continuous line, I don't even know what that means. The value in between any continuous line. Okay? Maybe you're trying to say the same thing that I want you to, but your terminology is a little bit off. So please be sure that you're knowing how to express mathematics. This again is saying that it's only a point. No, it's not. Okay? It's an interval. It's called a closed interval. Okay, and on the way down here, now all numbers between and including, yes, that says the same things what we did before. It's not symbolic, but it is in words. Okay, so be sure that that you are understanding the notation, because it says the function is continuous on the closed interval. That means that if we have a less than or equal to x, less than or equal to b, okay, are we talking input or output values here? Oh, be careful. Be careful. The function is continuous on the closed interval. Input or output? Input. Okay? And k is any real number between f of a and f of b. What is k? Input or output? Read that again. K is any real number between f of a and f of b. It is an output, yes. This is an output. Just like f of a is an output, f of b is an output. Okay, those are output values. How do we know that? Because it is between two other output values. So we're saying that it's continuous on the inputs between a and b, including a and b, and that there's some other output value, other value k, between two other output values. Then there is at least one number c. What is c? Input or output in the closed interval a, b? Input. Okay, it is another input value in the closed interval a to b, including a and b, such that, and here we go again, such that, can you see that from where you are? F of c equals k, such that, is f of c representing an input or an output? Output. Is k representing an input or an output? Output, such that the output at the input of c has the same value as the output value k. What on earth? How does that look? What are we going to do with that? Well, let's see. Let's try it and see what we've got. Here's a, and here's b. The first thing is that the function is continuous. So if I say this is f of a, because I can include it, right? It's part of the closed interval. And this is f of b. So here's f of a. And here is f of b. It's continuous. I don't know how this looks. It could look something like that, for all I know. It's continuous, though. Whatever it is, it's continuous. It says, okay, this function is continuous on the interval, and k is any real number between f of a and f of b. Where would I show k on this? Yeah, right here. Somewhere in here is a value k. It's an output value between f of a and f of b. Then, there's at least one number c. C is somewhere in the interval. It's an input. So c is somewhere down here, such that f of c, the output of that value, has the same output as k. So let's see. Right there. So that could be c. Its output is k. Is it between a and b? Sure. Okay, there's another one. That's another possibility for c. Why? Because its output is equal to k. Is there another one? Yep. Right there. So I have three possibilities on my little graph that would qualify. Are any of those c's in the interval between a and b? Yeah. Are there outputs between f of a and f of b? Yeah. So this little intermediate value theorem is pretty neat because it guarantees that if it's continuous, and I have a continuous function and I have a value between two other outputs, that there's got to be some input that's going to give me that output. That's what that function says. Well, how do we use it? And that's the more exciting thing. Here's an example. Explain why the function, what's my time doing here? Oh,